Practice 9.4, questions number 1. The diagram on the right shows the front view of the dollhouse built by Melly. The color parts is the veranda roof of the dollhouse. PTS and PQR are straight lines. A. Calculate the area of the roof QRST. To find the area of the QRST, we're going to use the area of the PSR and minus it with the triangle PTQ. The triangle PTQ is a right angle triangle. Therefore, we can find the length of TQ using the Pythagoras theorem. So it will be the square root of 5 square minus 4 square, which is equal to 3. So we can find the area of the triangle PTQ using the formula 1 over 2 times base times height. So it will be 1 over 2 times base, which is the 4, and times height, which is the 3. So the answer will be equal to 6. As for the area of the triangle PSR, as we already have the length of PS and PR, so we just need to find the included angle at the P here. Then we can solve the area using the formula 1 over 2 AB sine C. So refer to the right angle triangle PTQ, the angle P. So this TQ will be the opposite side, whereas this 4 cm, the PQ will be the adjacent side, and this 5 cm, the PT, is the hypotenuse. So we can use any trigonometric ratios, sines, cosines, or tangent to find the angle P. So let's say I choose cos here. So cos angle P is equal to adjacent over hypotenuse. So here it will be 4 over 5. So the angle P will be the inverse cos of 4 over 5, which is equal to 36.87. So area PSR will equal to 1 over 2 times 11 times 14 times sine 36.87, which is equal to 46.20. So area QRST will equal to 46.20 minus 6, which is equal to 40.20. Questions B. Point U lines on PR such that SU equal to SR. Calculate the angle SUP. So these questions B involve the ambiguous case. As the points U lines on PR, then we need to swing the points R to the left. So this blue dot will be the points U, and this will be the straight lines SU. And the angle SUP that we want to find will be the angle here. So based on the triangle PSR, we have two sides and one included angle. Therefore, you can find the length of SR. So here the length SR is opposite to the angle P. So using cosine rule, SR square is equal to 11 square plus 14 square minus 2 times 11 times 14 cos 36.87. So the length of SR will be the square root of the answer here, which is equal to 8.402. So the length of SU will be the same as well. So now we can find for the angle R here. So this angle R is opposite to the length of SP, and this angle 36.87 is opposite to the length SR. So using sine rule, we can solve for the angle R. So here 11 over sine angle R, this is equal to 8.402 divided by sine 36.87. So the sine angle R will be 11 times sine 36.87 divided by 8.402. So the angle R will be the inverse sines of this answer, which is equal to 51.77. So the triangle SUR is an isosceles triangle. Therefore, the angle of the SUR will be equal to 51.77 as well. So as PQR is a straight line, so the angle SUP will be 180 minus 51.77, which is equal to 128.23. Questions number 2. The diagram on the right shows the positions of an oil rig, a tanker, and a helicopter. The bearing of the helicopter from the tanker is 40 degrees. Given the distance between the helicopter and the tanker is 13 km, whereas the distance between the helicopter and the oil rig is 10 km. Calculate the distance in kilometer between the tanker and the oil rig. So here I'm going to label the distance between the tanker and the oil rig as x. So based on the diagram, the oil rig is on the east side of the tanker. Therefore, the angle from here will be 90 degree. Then the angle here will be 90 degree minus 40 degree, which is equal to 50. So now refer to the triangle form here. This 50 degree is opposite this 10 km, whereas this 13 km is opposite the angle formed at the oil rig here. Let's say we label the angle here as P. So using sines rule, we can find the angle P. So 13 over sines angle P, this is equal to 10 over sines 50. So sines angle P, this is equal to 13 times sines 50 divided by 10, which is equal to 84.78. So now we can find the angle at the helicopter here. Let's say the angle here, we label it as Q. So angle Q will be 180 minus 84.78 minus 50. This is equal to 45.22. So now using sines rule, we can find the length of x. So this x is opposite to the 45.22, and this 10 km is opposite this 50. So using sines rule, this will be x over sines 45.22. This is equal to 10 over sines 50 degree. So x will equal to 10 over sines 50 degree times sines 45.22. So the answer is equal to 9.266 kilometer. Questions number 3. The diagram on the right shows a gift box in the shape of a cuboid. A. Calculate the area of the plans ACQ. The plan ACQ is in the shape of a triangle. So if we are able to find the length of each side in the triangle ACQ, then we can find the area using the Heron's formula. First, we're going to find the length of AC, which lies on the plans ABCD. The plan ABCD is a rectangle and the AC is the diagonals. So we can find the length of AC using the Pythagoras theorems, as the AC is the hypotenuse in the right angle triangle ADC. So AC will be the square root of 8 squared plus 4 squared, which is equal to 8.944. As for QC, it lies on the plane BCRQ. The plane BCRQ is also a rectangle, so we can also find the length QC using the Pythagoras theorem. So QC will equal to the square root of 8 squared plus 6 squared, which is equal to 10. And as for AQ, it lies on the planes ABQP. So here we can also find the length of AQ. using the Pythagoras theorem, it will be the square root of 4 square plus 6 square, which is equal to 7.211. So now we already have the length of 3 sides in the triangle ACQ. So we can find the area using the Heron's formula. So first we are going to find the semi-perimeter. It will be 7.211 plus 8.944 plus 10 and divide by 2. This is equal to 13.078. So area of plans ACQ will be square root of 13.078 times 13.078 minus 7.211 times 13.078 minus 8.944 times 13.078 minus 10. The answer is equal to 31.246. B. Hence, state another plane which has the same area as the planes ACQ. So it has to be the planes which has the same measurement as the planes ACQ. So for the diagonals AC, I'm going to replace it with the diagonal BD. For diagonal QC, it will be replaced by diagonal BR. And we will connect the points R and D. So the length of the diagonal RD will equal to the length of QA. So the plans BDR will have the same area as the plans ACQ. Question number 4. A ship sailed for 20 km to Port Bentara at a bearing of 120 degrees from Port Astaka. Then the ship sailed for 30 km to Port Jindai at a bearing of 225 degrees from Port Bentara. Calculate the distance and the bearing of Port Jindai from Port Astaka. So based on the information here, the Port Astaka will be the reference point. So let's say this is the locations of the Port Astaka. So the Port Bentara is at the bearing of 120 degrees from Port Astaka. And the distance is 20 kilometers. Then the point here will be the locations of the Port Bentara. So later when the ship sailed to Port Jindai, the Port Bentara here will become the reference point. So the bearing 225 will start from the north here, clockwise until here. And the distance is 30 kilometers. Then this will be the locations of the Port Jindai. The straight lines with red color here will be the distance from Port Jindai to Port Astaka. And here, the locations, if you connect all of them, it will be in the shape of triangle. So let's say I label this distance as x. So this x is opposite to this angle here. So if we are able to find the angle here, then we can solve the x using the cosine rule. So first we're going to find the angle here. So when we start from the north until the west here, the angle will be 270. Let's say we name the angle here as P. Then to find the angle P, it will be 270 minus 225, which is equal to 45. Next, for this part of angle, it is equal to the angle here. As the horizontal lines here, they are parallel. So these two angles here is the alternate angle. So here is going to be 90 degree. So 120 minus 90 degree, the angle here will be 30. So the angle here will be 30 as well. So now we can find the distance, which is the x, using the cosine rule. So x squared is equal to 20 squared plus 30 squared minus 2 times 20 times 30 cos 75. The x will be the square root of this answer, which is equal to 31.455. So next we want to find the bearing of Port Chindai from Port Astaka. So in this case, the Port Astaka will become the reference point. So from the Port Astaka, from the north here, until the red straight line here, this will be the bearing of Port Chindai from Port Astaka. So here we just need to find what will be the angle here. And later on, we're going to add it with 120 degree. Then we're going to get the bearing. Let's say we name the angle here as Q. So this Q here is opposite this 30 kilometer. So we know the X already, which is opposite the angle 75. So using sine rule, 30 over sine angle Q, this is equal to 31.455 divided by sine 75 degree. So sine angle Q will be 30 times sine 75 degree divided by 31.455. So the angle Q will be the inverse sine here, which is equal to 67.11. So the bearing of Port Chindai from Port Astaka will be 120 degree plus 67.11, which is equal to 187.11 degree. Question number 5. The elevation's angle of the peak of a mountain from Aman is 20 degree. Then Aman walked horizontally toward the mountain that is 800 meters away, and the elevation's angle becomes 45 degree. Estimate the height of the mountain from the label of Aman positions. So let's say this is the position of mountain and Arman. Then the elevation's angle of the peak of mountain away from Aman is 20 degree, will look like this. And from these informations, Aman will move closer towards the mountain. And the distance here will be the 800 meter. And the elevation's angle of 45 degree will be here. So here we want to estimate the height of the mountain. So now let us focus on the triangle that we draw. The angle here will be 90 degree. So the angle which is next to the 45 degree here, we can find it by using 180 degree minus 45, which is equal to 135. So next, we can find what will be the angle here. So using 180 degree minus the 135 and the 20, so the angle here will be equal to 25. So now let us focus on the triangle in the green color here. This 20 degree is opposite to this length, whereas this 800 meter is opposite to the angle 25. So let's say I label the length here as x. So we can find the x here using the sine rule. So x over sine 20 degree, this is equal to 800 over sine 25. So x is equal to 800 over sine 25 times sine 20. which is equal to 647.43. So now let us look at the right angle triangle in green color here. Using the angle of 45, the heights of the mountain will be the opposite sides, whereas the length of x here will be the hypotenuse. So using the trigonometric ratios of sines, which is equal to the opposite sides over the hypotenuse, then we can find for the heights of the mountain. So sines 45 degree will equal to the heights of the mountain over the hypotenuse, which is 647.43. So to find the height, it will be sines 45 degree times 647.43, which is equal to 457.802.